Hello everyone, welcome to the INS lecture series. So in this particular session, that is lecture number 10, we'll study the topic modes of operation. In modes of operation we have 5 subtopics. The first one is electronic code book ECB, then second is cipher blockchaining CBC, then cipher feedback CFB, output feedback OFB, and counter CTR. Now what is the meaning of modes of operation? In the previous sessions we studied the topic that is the modern ciphers, that is the DES, and some forms of DES as well as AES. Now these two modern ciphers, they are block ciphers, because DES it encrypts a block of 64 bits at a time and AES 128 bits at a time. They cannot encrypt data which is less or more than this. But in real world we may have a data which may be larger than 64 or 128 bits, and it may be less than. Sometimes we need to encrypt a byte of data 8 bits at a time. Then we cannot this would be impractical. Okay, it won't be possible to use those things. So for using this modern ciphers, we need to devise some way, and that way is actually the modes of operation. So here we can see there are 5 modes of operation. The first is electronic codebook CBC and CFB, OFB and CTR. Let us see them in detail. So we begin with the first mode of operation, that is the electronic codebook, that is the ECB. Now before starting with the modes of operation, we must understand the concept. See, irrespective of any of the mode of operation, whatever plain text message we have, suppose we have plain text message which is of m bits, so this entire message is divided into some blocks, okay, of equal length. So maybe like this, p may be of m number of bits, so this is divided into smaller number of blocks, p1, p2, pn. So there are, we can say, n number of blocks. Each block is of small n bits. Now this n, it may depend on what method we are using. It may be like, let us assume it may be 64 bits or it may be of 128 bits. So we divide the entire plain text into some number of blocks, and each block is of same size. Now here a issue may arise, like suppose if our original message is suppose of let us say a multiple of 64. So if we have 640 bits message, so here clearly we will have 10 number of blocks, p1, p2 up to p10, all blocks containing 64 bits. But in case if instead of 640, suppose we have a block size of suppose 630. Now in this case, this is not a multiple of 64, so the last block, it may contain 54 bits. It may contain 54, or actually sorry, it should be 640, so it would contain actually, yes, 54 bits. Okay, it will contain the last block will contain 54 bits, but we want 64 bits, the last block. So 10 bits padding is done, so that the last block also becomes of 64 bits. So this we will add 10 bits, so it becomes 640. So it must be a multiple of 664 in case if all the blocks are containing 64 bits. So in case if last block is having less number of bits, some padding is done to make it a multiple of 64. So now let us come to this first one, that is the electronic codebook. Now in electronic codebook, what happens, we divide the entire message into small number of blocks. As we can see, we have this p1, p2 ... we have n number of blocks, each containing n bits, and every block is encrypted by an algorithm, encryption algorithm. This is the algorithm using the K key. So this key is common to all the methods. Even at the decryption side, the same key is used. Okay, so same key is used for encryption, same key is used for decryption. So let us see, in this case we take the first block p1. This block p1 is encrypted using the key, and we get the first ciphertext block. Same way, the second plain block is taken, it is encrypted using the same key, we get c2, and so on. At the receiving side, the ciphertext block is received. This ciphertext block is decrypted, so instead of here we have D, using the same key, and at the receiving side we cover this plain text block first, second, third, and so on. So this is how it works. Then this I have explained the working. So the very first step, as we can see, the data is divided into fixed size blocks, either 64 or 120 depending on the algorithm we are using. Then we encrypt the message, okay, and form the ciphertext, and at the receiving end the message is decrypted block by block. Now the advantages of ECB, the first is the simplicity. As we can see, this is the simplest mode of operation, so it makes us easier to implement and understand, and we can achieve parallelism. So here, as we can see, every block is actually independent of the other. So if we divide suppose the plain text into 10 blocks, we can encrypt 10 blocks at the same time. So this ciphertext block only depends on this plain text. This ciphertext block only depends on this plain text. So if we have simultaneous machines, we can actually do simultaneous encryption and achieve parallelism, and we can speed up the operation. So these are the advantages of ECB. Now the disadvantage part, the first is the lack of security. Now why it is lack of security? Because suppose in case if we have a plain text block P1 and suppose another block, let us say P3, okay, these two blocks P1 and P3, if they have the same plain text, then their ciphertext will also be same. So this plain text and this plain text, if both are same, or in any case if any two blocks are identical, then their ciphertext would also be identical. So it may be vulnerable to attacks. Attacker can judge what is there in the plain text, it will try to judge, and this is also susceptible to known plain text attack. So if an attacker knows or guesses the contents of a specific plain text block, then it can identify those blocks in the ciphertext also. So these are the disadvantages of ECB. Now next is the cipher block chaining. Now this cipher block chaining, in this case what we observe, the very first process is same, that we divide the plain text into number of blocks. So we can have n number of blocks, and the size of the block is fixed. Now apart from that, as we can see in the diagram, we are using this IV. This IV is the initialization vector. This can be any value which is selected by the sender, and of course receiver also knows this value. So what is done is we take the first block, okay, first plain text block is taken, and it is XORed with the IV, okay, and the output of this is encrypted using the key, okay, and we get the ciphertext, the first ciphertext block. Now this ciphertext block, okay, it is XORed with the second block. So see, in the first case we have this IV, okay, so this IV is fixed, and sender receiver know this, and this both the plain text and IV, they are XORed, and we encrypt that output using a key, and this is the ciphertext. Now this ciphertext block, it is sent to the receiver, and it is also used for XORing with the second block, and after XORing the data is encrypted, it becomes the second ciphertext block. Now this ciphertext block is also sent to the receiver, and it is also XORed with the third block, and so on. So therefore this is called as cipher block. We are forming a chain. So this is how it is done. Now this is the working: initialization, the XOR operation, the encryption, the ciphertext formation, and the decryption. I will share this text in the description section. You can download from there. And these are the advantages. We get security. Now as compared to ECB, we get a good security, because in this case, if two plain text block, if they are same, they won't get the same ciphertext block. Now why they won't get? Let us see. In this case, suppose this P1 and this P2, both plain text block are suppose identical. So here we are actually XORing with IV, so this will be different. We will get something output, and this is encrypted. Now this output we get as the C1, so plain text is P1, we get the ciphertext as C1. Now C1 is sent, It is also used in the second operation of encrypting with the P2. So what we do, we XOR this content with the P2. So what it is observed is that this C1, it depends on IV and P1, and this C2, it depends on C1 as well as P2. So because the dependencies are not same, so it is natural that we won't get the same ciphertext block. So even if the plain text block are same, ciphertext block would not be same. Then it also gives the diffusion process. Diffusion means was if we make a small change in the plain text, then there will be a large change in the ciphertext. And we also use an initialization vector in this case. So this IV adds some more randomness to the encryption process. And then let us come to the drawbacks. So there is some overhead in this case. Overhead means what? CBC requires sequential processing. Why it requires sequential processing? Because to encrypt all the blocks, suppose we are encrypting P1, we get output as C1. Now this C1 is used for encrypting P2. Okay. Then this P2 we get output as C2. This C2 is used for the next process. So until and unless we get the previous ciphertext, we cannot go for the other blocks. So P2 depends on C1, P3 depends on C2. So there is a dependency, we cannot go for parallel operation. Then one more drawback is there. It is susceptible to bit errors. So there is something called as error propagation. Now what is the meaning of error propagation? Suppose here if there is an error in this, of course error can occur. So suppose if there is an error in this while doing encryption or doing any operation, some error has occurred in this calculating this ciphertext. Now this error goes into the next block. Now because this was already corrupted, so it will corrupt all the further blocks. So this error in the first operation can propagate in the other blocks also. So this is called as error propagation. This was not there in ECB, but this is there in CBC. So this is how the CBC works and the advantages and disadvantages. Now the next one is Cipher feedback mode. Now see what this Cipher feedback mode, it is designed to be a stream cipher. Whatever two we studied, they were purely block cipher, but sometimes we need to encrypt a stream cipher, encrypt a stream data. It may be of 8 bits or maybe 1 bit. So what is done in this case, as we can see, we start with an initialization vector. So this is the initialization vector, random bits, okay, and then this IV is actually encrypted with the key. So suppose if this, let us assume this is of 64 bit. Let us assume this IV is of 64 bit. This is encrypted using the key, and this is what we get, the encrypted IV. Now out of this 64 bit, the leftmost 8 bit, we take this leftmost 8 bit and we XOR it with the plain text. Now in this case, let us assume the plain text is of 8 bits. So we take 8 bits of the plain text, the first plain text block. So of course here also we divide the total entire plain text into number of blocks. Here the block size of 8 bits. We cannot say it a block, but we can say that it is 1 byte. So this plain text, the first plain text of 8 bits is encrypted with the leftmost 8 bit, because this is actually 64 bits. So we take the red portions of 8 bits and we XOR it and we get the ciphertext. This is also 8 bits. Now this ciphertext, we need to add some randomness. So what is done is, in this case, this ciphertext which is of 8 bit, it is of course sent to the receiver, and this 8 bits, they are appended at this point of the IV. Now IV was 64 bit. If we add this, it will become 72. So in that case, the leftmost 8 bits, they are discarded and this is appended, and this process continues. Okay, this process continues for all the further blocks. So we get randomness, and we can also use this particular for the this stream as a stream cipher. Okay, this is the working. Okay. And these are the processes. Encryption, feedback loop is there, and we have decryption. So these are the advantages. We can use it as a stream cipher, for stream cipher, okay, for encrypting the data which is in the form of stream, that is either 8 bits or 1 bit. Then there is a self synchronization. So CFB mode inherently synchronizes the encryption decryption process because each block depends on the previous one. And of course the error propagation is actually limited in this case as compared to the previous case. Okay, so it limits the error propagation. If an error occurs in the ciphertext, only the corresponding block of the plaintext affected and the rest of the data remains the intact. Okay, because we are only operating on the 8 bits, not an entire block. Now disadvantage, as we see the performance, this CFB is slower than the other two modes because each bit or byte depends on encryption of the previous block. So there is a sequential processing. Then there is no way of error recovery. So if there is any error, if there is an error propagation, we cannot recover. And there is a sensitivity of the IV use. So IV, the initialization vector must never be reused with the same key. So it can lead to security lapses. Next is the output feedback mode, that is the OFB mode. This is also, of course, can be used as a stream cipher. Only the difference, if we compare the diagram, we can understand from the diagram itself the basic difference. What is the basic difference from the diagram? In output feedback mode, what we see is that this leftmost 8 bit, it is actually appended to this. In the previous case, this was appended, okay, in the previous case, but here this is appended, and rest all the things remain the same. So if you observe this diagram, as you can see in this particular diagram of CFB mode, what is happening is this ciphertext which we get, it is sent as well as it is also appended here, and now what we are using, that is output feedback mode. Okay, so in output feedback mode, whatever we are getting, the leftmost bit which is actually used for this encryption is also actually appended here. Okay, now what advantage we get in this case? The advantage we get is we can reduce the error. Now how we can reduce the error? So in the previous case, CFB mode, because this ciphertext was actually appended here, it may happen that there may be some error here also. So there are two chances of error. Either the error can occur at this stage or at this stage while doing the calculation, when the bits are we are doing the calculation. So here, if we are skipping, if we are not sending this part and we are sending this part, so 50% error chances are reduced. So this is the advantage we get in OFB. So these are the work. This is how it works, which I have explained. I will share this PDF link in my description section. We can actually download from there. So these are the advantage and disadvantage. They are almost the same as the CFB mode. Now the last is the counter mode. Now in counter mode, as we see the previous case, there are some advantage, disadvantage in ECB and the other modes. So we can actually get away with this. So we can add some randomness, and we can also achieve parallelism, and also get away with that error propagation using this counter mode. So in counter mode, we have IV. We start with an IV, and this IV is of course randomly selected by the sender, and user also knows what this IV is. So this IV is actually encrypted using the key, and out of that we select the n bits. Suppose if the plain text is of n bits, we select that n number of bits. So this is this part. This part K1, this is the first key K1. Okay, this is applied, XORed with the plain text, we get the ciphertext. Now in the next case, now the name counter is given because this IV, it will have some initial value. So this initial value is updated for every block. So suppose if this value was 1 2 3 4 5 6, suppose, okay, so in the next it will become 1 2 3 4 5 7 8 9 10 and so on. So this count will increase for each and every block. So what advantage we get in this case is that in case if this two plain text block, even if they are same, the ciphertext won't be same because this is changing for each and every block. So we get the there is a safety here. Okay, we get more security. Then the second thing, in case if there is an error in this C1, this error will not be propagated further because this, whatever we are doing calculation in the previous blocks, they are not used for the second blocks. So there is no error propagation, and we get randomness, and of course we can also achieve parallelism. So if we have 2 3 machines we can actually do calculation, we can randomly, we can actually do simultaneously, we can encrypt many number of blocks at the same time. So this one is having that advantage. Okay, those are the advantages of that. Then of course this is also everything has some drawbacks. So there is a sensitivity to use to the IV use. So we cannot use IV, it cannot be reused with the same key, it can compromise the security of the encryption process. And the initial counter value, of course the initial counter value should be selected carefully to avoid collisions or repeated counter values in the long term usage. So we need to update this count every time. That will be more better for the security reasons. So that's all for this particular session. Thanks for watching.